Hi, today we're going to take a look at solving linear equations. And here's a polynomial equation that's linear. Ax plus b equals c. A helpful thing is to be able to recognize the type of equation you have. It's not such a big deal now when you're first learning how to solve them, but later when you get closer to your final and you have all different types of equations together, it really comes in handy. So what makes an equation linear? Your highest exponent is 1. Polynomial equation, and you do not see any exponent with your variable. No x squared, no squared root, anything like that. So, one of the concepts that we have to focus on when solving any type of equation is we have to keep both sides of that equal sign equal, okay? So, let's suppose we start with 3 equals 3. It's a true statement, but if we add 4 to only one side of the equal sign, it's no longer equal. We have 7 equals 3. So in order to keep it equal, we also have to add 4 to the right side. Then we get 7 equals 7. So even though we've changed the value on both sides, we've still maintained the integrity of the equal sign, okay? So it's still equal, still balanced. It also works for subtraction. If you subtract 5 from the left, we also have to subtract 5 from the right, therefore it stays equal. And it works for addition and subtraction, but also for multiplication and division. If we multiply both sides by 6, we get 12 equals 12. Divide both sides by 3, we get 4 equals 4. So as long as we maintain the inequality, we're safe. Now what skills do we need in order to solve linear equations? We have to be able to combine like terms, distribute, and know a little bit about inverse operations. Now, when we talk about operations, we're referring to addition, subtraction, multiplication, and division. But what makes them inverse? Technically, definition of inverse means that they reverse the effect of each other. But what does that mean to you and me? Basically, they undo each other. Think of addition and subtraction. They're paired up, they're opposites. Multiplication and division are paired up, they're opposites. So those are the two groups of inverse operations that undo each other that we're going to use when solving linear equations. Addition and subtraction, and multiplication and division. So, whenever you solve any equation, doesn't matter if it's linear, quadratic, or what, our goal is to get the variable by itself. We want to know, what does x equal? X equals some number and we need to find it. So suppose we have this original equation here. It's linear, polynomial, where your highest exponent is 1. And we want to figure out, what does x equal? So we're going to manipulate that equation until we can whittle it down to just x, equal sign, and a number. So that's where I want you to think when you get to a test and you get really nervous. What's my goal? I'm going to solve it. I need to get x equals a number. So what's in my way? How do I get there? So right here we find the x. It's on the left-hand side. Now here's a 2 attached to it. So you've got an x term, but here we have a constant. So the first thing we want to do is to get the x term alone. So we're going to undo that subtraction, that little minus sign, by adding the 3 to both sides. So we add 3 here, there's your equal sign, add a 3 there, we get 2x equals -6. Same problem here, we've got the term by itself, but I still have a 2. So now I want to whittle it down a little bit more and get rid of this 2. So what's that operation in between the 2 and the x? Multiplication. And how do we undo multiplication? Division. Good. So to get the x alone, we're going to undo the multiplication using division. So if we divide both sides by 2, 2 divided by 2 is 1, which is what we wanted. 1x equals -3. Yay! Now, that was just kind of a basic, straightforward problem, but what if it gets really messy? Don't let those problems intimidate you. For example, let's suppose we have this guy. It's kind of long. I want you to remember that an equation is like two expressions set equal to each other. So we can just cover up the equal sign in the right-hand side and figure out, how can we simplify this so it's not so ugly? Yeah, we can get rid of that parentheses by distributing. So let's go ahead and do that. If we distribute the 3, we end up with 6x minus 15 equals. And then we can focus just on the right-hand side separately, where we have two like terms here, the 2x and the minus x. If we combine those, we'll get a single x, and then we still have our plus 5. Awesome, so the sides are simplified, But remember, our goal is to whittle it down to get x equals a number. How many x's do we have? 2, right? One on the left, one on the right. So we need to use addition and subtraction to move one of those x terms. So I'm getting rid of the x here. I'm going to subtract the x, but again, we have to do it on the other side as well. That leaves us with the 5x. Bring down your minus 15 equals 5. So as you're working it, be sure you're bringing down everything. This is 0, so that's why it's not showing up, the plus 5. And if you kind of focus on that, you're not going to miss anything. That's where the careless errors tend to come in. So now we're back to the other example. We have 1x, it's on the left, so let's get this term by itself by adding 15 to both sides. Let's move it up here so we have a little bit more room. And now we want to get the x by itself by moving that 5 using division. X equals 4. Now I want you to try. Here's 2 examples. Pause the video when you're ready. Try them on your own, and then we'll work them together here in a minute. Pause it. Yeah, pause it while I'm making this face. Okay, let's see how you did. The first equation, it's linear. You got a polynomial where the highest exponent is 1. And we need to get this x term by itself, so we're going to undo the addition of 5 by subtracting 5 from both sides. Now, for some of you, if you're having trouble reminding yourself that you have to do it to both sides of the equation, highlighting it would help, just to make sure that you see 2 every time that you create something on one side, that you're creating it on the other. A common mistake that we see here often is because this is a negative 3, they want to add 3 or divide by a positive 3. They're wanting to do the opposite of this sign. But remember, we're doing opposite operations. It's not 3 minus x or x minus 3. It's negative 3 times x. We're multiplying. So what undoes multiplication? Division. Good. We're whittling it down. So we're going to divide both sides by negative 3. And again, we can highlight. Negative 3 divided by negative 3 is a positive 1, which is our goal. We want just the x by itself. And remember, negative divided by negative is a positive, so we're left with a positive 7/3. Your teacher may want you to change it to a mixed fraction, which is fine. 3 divides into 7 twice with a remainder of 1, so we're left with 2 1/3. Okay, let's take a look at the next one. This one is a little bit more messy, so we have to simplify both sides of the equation first. Here we have a 2x and a 3x that we can combine, okay? 2 like terms here. That would give us a 5x, and then we still have that minus 5. And on the right-hand side, we've got this multiplication, so we can distribute and get rid of that parentheses, 2x minus 8. So now it's not as intimidating. You just took it one step at a time. If for some reason you get kind of overwhelmed by visualizing everything, keep a second piece of paper with you, a blank second piece of paper with you. Cover what you've already worked with, and then just focus on what's left, okay? So here, remember, we're trying to whittle it down to get x by itself, but now you have x on both sides of the equation here. So we've got to move one of them. I chose the 2x, but it doesn't matter which one. You can move the 5x, 2x, you'll get the same answer. So here, we're going to subtract 2x from both sides. Again, we can highlight to make sure that we've done it to both sides of the equation. Oops. So we'll be left with a negative 8 on the right-hand side, and on the left, that gives us a 3x minus 5. So now we're getting closer. Our x is, you see only one of them now. It's over there on the left. So let's get the constants together. Let's go ahead and move this 5, undo that subtraction using addition. Dun, dun, dun. And that leaves us with a 3x equals a negative 3. I'm going to move it over here just so we have a little bit more room. Okay, and now to get the x by itself, we're going to undo that multiplication by division, dividing both sides by 3. Oops. I was thinking of the other problem apparently. Dividing both sides by a positive 3, because it's this 3 that we're getting rid of. Because 3 divided by 3 gives us a positive 1x. That's what we wanted. Negative 3 divided by 3 is a negative 1. There's one more example, so don't hang up on me yet. I know this wasn't on the slides that we were looking at, but I wanted to be sure and give you an example with fractions in it. I know fractions tend to just scare students a lot, but I don't want you to be afraid of them. Remember, fractions mean division. You know, this is 2 out of 3, but it also means 2 divided by 3, 1 divided by 2, the 2/3 and 1/2. What undoes division? Multiplication. So what you need to do to figure out how to undo that fraction is what undoes division? Multiplication. So let's take a look at the least common denominator of our two fractions here. Least common denominator would be 6. Now, what would we do with that 6? We're going to multiply to undo the division part. So if we multiply the left-hand side, there's our 2/3 x minus 4 by 6, and the right-hand side by 6. Basically, we're going to distribute. So again, we've multiplied the left-hand side by 6, the right-hand side by 6. But over here on the left, we're going to distribute. Normally, most people only show this third line where they've distributed the 6. I'm going to put the 6 after the minus 4 so it doesn't get too confusing there with the minus sign. Doesn't really matter, but just in case. So notice everybody gets multiplied by the 6. I wanted to show this step so you know that we are technically doing it once on each side. We multiply the left-hand side by 6. We multiply the right-hand side by 6. But we did distribute. The reason we're doing this is every denominator divides into that LCD evenly. Therefore, we no longer have a denominator. For some of you, it might help to write those LCDs over 1 just as a visual, because some of you are still having trouble with your fractions. And that way you know that it's the 1 times the 3 and the 2 times the 6. So 3 divides into 6 twice. Now this denominator is 1, so we don't need to write it. Same thing here. 2 divides into 6 3 times. So now this denominator is 1, so we don't need to write it. All we do is now multiply across and simplify. So here we have 2 times 2x, which gives us 4x. 4 times 6 is 24. And 3 times 1, which is 3. It's a little bit nicer. You don't have the fractions anymore, and we can solve it like we did the other 2 examples. So if we add 24 to both sides, oop, changed my method there. That's okay. That leaves us with a 4x equaling 27. And then 4x equaling 27. We're going to undo the multiplication between the 4 and the x by dividing both sides by 4. 4 divided by 4 is 1. That was our goal. So we're left with x equaling 27/4. That's an improper fraction. It's improper because the higher number is on top. Mixed fraction, we can divide. 4 goes into 24 6 times with a remainder of 3. So we get 6 3/4 as our mixed fraction. Ta-da! So how did you do? Double check and just kind of see, were your errors careless or were you really clueless? Do you need to watch the video again? And also remember, don't let your pride keep you from passing. Talk to your teacher, your friends, see more videos. There's plenty of resources out there, okay? So ask for help. A few things to remember. If you do not see any variable exponent in a polynomial equation, then it's linear. Your goal is to get the x by itself. You want to know what x equals, so you got to whittle it down. And then we're going to separate our variables from our constants to help us get our x alone by using inverse operations to undo each other, to get rid of those obstacles. Well, I've had fun. I don't know about you, but hopefully it was better than drinking your own bathwater. Wasn't too bad. And I'll see you next time for the next video.